Hello world, my name is David Malin and I teach CS50, which is Harvard's introductory course in computer science for majors and non-majors alike. An amalgam, of course, is generally known as CS1 and CS2 elsewhere. Now CS50 is fairly unique here on campus as well insofar as we teach multiple languages within this introductory course. We start off the course with a bit of Scratch for just a week or so to give students a hands-on sense of what they can do programmatically ultimately with a graphical user interface to boot. But we then spend much of the semester on C and followed by Python as well, exploring arrays, algorithms, data structures, memory management, and much more along the way. Toward the end of the semester, we introduce students to a bit of SQL, HTML, CSS, and JavaScript so that they have a web-based framework with which to develop their own web apps or even mobile apps nowadays. And ultimately, about half of the students will continue on from this course in further studies in computer science, but another half will generally return to their own fields in the arts, humanities, social sciences, physical sciences, and ideally apply lessons learned and practical skills gained to domains of interest to them. Unfortunately, supporting all of these languages is a bit of a challenge unto itself. Now, students could certainly download and install the requisite software on their own Macs and PCs, and I dare say the options therefore abound. And I dare say we've probably tried most of these solutions over the years. Unfortunately, the challenge is that students invariably run into technical support challenges on their own, which in the worst case is itself an impediment to actually staying engaged with or even continuing on in the course if they can't even get Hello World to work on their own machine. And it's also a challenge at scale with lots of students and only so many TAs and teachers to actually support those students with the same. Now, there's increasingly server-side possibilities, and here too we've tried so many of these. The upside of server-side solutions, of course, is that we can pre-configure and pre-install all of the requisite software for students, but it's not without its own technical support headaches for ourselves and also not without cost. So what we thought we'd do in this talk is share with you our experience specifically containerizing CS50 using a technology generally known as Docker, whereby we can automate a lot of the setup of this course and in fact others to make students' onboarding experience and ultimately offboarding experience all the more effective, both technologically and educationally as well. Our thanks to so many of CS50's team, both here on campus as well as off, as well as to our friends at AWS, GitHub, Microsoft, and beyond. And in fact, let me disclaim that during a sabbatical and thereafter, I did spend some time myself as a professor in residence with GitHub, but all of the design decisions you're about to see we had actually made before that particular opportunity arose. Now, here's what we did some 19 years ago when I first took over the course. Students were SSHing to, and prior to that, telnetting to, a central Linux cluster on campus on which they had a shell account as well as a home directory that was NFS mounted and therefore available to them throughout campus. The upside of this central architecture was that students could have at their disposal all of the software pre-configured. Everything was automatically backed up for them. Of course, it was fairly headless in the sense that there was no opportunity really back then for graphical user interfaces, and the interface itself was fairly arcane, being only a CLI or command line interface. For those least comfortable with computers, this alone was a bit of a challenge, but most importantly early on, insofar as this particular cluster was managed by the university, it was very hard for us pedagogically to do in software exactly what we wanted to do for the course. For instance, it was a challenge to install the latest versions of software, let alone support for things like SQL and other languages too. We didn't have root access or administrative access, and so we couldn't do that or make other changes. Invariably too, because the IT staff on campus would typically work 9 to 5, and our own students and TAs and myself might work 5 to 9, invariably when problems went wrong, it was outside of business hours, at which point we might be at a standstill, unable to solve problems on our own. And so once the cloud began to get popularized some years ago, we actually re-implemented that same architecture ourselves in the cloud, essentially spinning up through AWS some EC2 instances, their so-called Elastic Compute Cloud, which were a bunch of virtual machines in the cloud. And we had some of those be compute for students where they could log in and write and run code. We had some of those actually serve as file servers to actually serve and replicate their data across the cluster. And they were also able to SSH into the same cluster from off campus, but we ourselves had administrative access, the upside of which we could do anything we wanted technologically and software-wise, and everything was exactly as we wanted it. A downside, of course, was the fact that when something went wrong, it was I, the system administrator, who had to now deal with everything, or some of our teaching assistants as well. So we shifted some of the technical support headaches from another group essentially to ours, and it did tend ultimately to get in the way of our practice of actual pedagogy and focusing on the course's curriculum as opposed to the course's technology. And so over time, we began to shift from server-side solutions to client-side again, but not necessarily software that students had to install on their own computer for Scratch, for C, for Python, for SQL, and everything else, but rather all they needed to do was download two things, a so-called hypervisor or virtual machine monitor, software like VMware or VirtualBox or Parallels or the like, and then a large downloadable hard disk image, a virtual hard disk image that contained inside of it a complete installation of Fedora Linux initially, later Ubuntu Linux, inside of which was the so-called CS50 appliance, a downloadable turnkey solution that had all the same software that students might need, as well as a more user-friendly graphical user interface. Now, this was game-changing, and in the early days of massive open online courses, or MOOCs, of which CS50 was early on part, it enabled us to scale not just to hundreds of students on campus, but tens of thousands of students off campus as well, who didn't therefore need a username and a password and some disk space on Harvard's own cluster. They could actually participate through OpenCourseWare in CS50 by simply downloading the virtual machine software on their own Mac or PC and participating actively in the course. As an aside, the course itself has historically been freely available for many years now as OpenCourseWare, but for those earliest of years, it was a very passive experience. Students could watch the lectures, they could try to do the course's homework assignments or problem sets, but they too would need to figure out how to install everything on their Mac and PC. So the CS50 appliance was therefore much more turnkey and enabled us to scale at just the right time. It too, though, was not without its technical support headaches. In fact, things with the hypervisor would sometimes go wrong. In fact, for a period of time, Windows was particularly vulnerable to bricking the virtual machine if a student so much as closed their laptop lid without properly shutting down the virtual machine. Simply because of bugs in the underlying hypervisors, sometimes they would actually lose their data. We tried to mitigate that by integrating Dropbox or other technologies into the appliance so that it would automatically back up somewhere to the cloud. Then, of course, Dropbox deprecated their Linux client, and so it just became a different type of technical support headache for us. It was a wonderful solution when it worked, but not without challenges. And this was also the period of time when netbooks were all the rage, whereby you might have fairly inexpensive and low power, low resource laptops in students' hands, and it was just hard to download a 1 gigabyte, 2 gigabyte virtual disk, as well as run another operating system on top of your own. And so we kept an eye out during this period for another cloud-based solution. And so I'll admit the pendulum kept swinging for us back and forth, and then we caught sight of something called Cloud9, with which some of you might have been familiar, which was an Amsterdam-based startup which made a web-based integrated development environment complete with its own terminal window. Indeed, underneath the hood was a Docker container, which was a different form of virtualization, if you will, containerization, whereby students had the illusion of their very own copy of Linux and their own home directory somewhere in the cloud into which they could log in. But they additionally had increasingly modern conveniences like tabs for writing the code itself and a graphical file Explorer at the side via which they could double click on and navigate files in a more Mac or Windows-like way without taking away the underlying muscle memory that they could develop from the terminal window, which for us was a key feature. All too many of these web-based environments we found at the time abstracted away too much, simply turning into a simple play button, all of the underlying complexity. But for us, in the first weeks, the first months of this course, we want students running a compiler at the command line. We want them running a debugger at the command line. We want them to understand commands like cd and ls and the like, so that even if eventually they want to move away from that, they at least have some very commonplace, very industry standard, very productive skills, as well as the concepts that they'll be exploring through the code as well. Now, Cloud9 was eventually acquired by AWS, and over time, we too kept an eye out for an alternative solution, insofar as the biggest catch for Cloud9 for us is that it really was this custom course-specific environment. Now, students could sign up for their own AWS account, but the reality is that so much of code in recent years has been done with client-side text editors, tools like VS Code, for instance, from Microsoft. And it turns out that around this same time we were looking, GitHub developed a version of VS Code for the cloud on the form of something called GitHub Codespaces, which is essentially their cloud-based hosting of the so-called Docker containers, as well as web servers that run the VS Code base itself, so that you can log into GitHub Codespaces and have a web-based programming environment quite like Cloud9's, but one using a, dare say, industry standard piece of software, as well as one that once students are sufficiently comfortable, they can download and install on their own Macs and PCs. And in fact, that's exactly the trajectory we have long wanted, whereby we want students at the very beginning of the course, when it's time to learn and write hello world, just log into this URL with your username and password and go. And then at the end of the semester, when students in this particular course are working on their capstone projects or final projects, which is pretty much a charge to do anything and anything of interest to them in software, using or not using the course's own lessons, at that point, we do want them ideally graduating from the course's own infrastructure, downloading and installing, and dealing with any technical support headaches 3 months into the course, not at course's start, in order to get their code running on their own computer so that once they exit CS50, they can stand on their own and no longer need any of the course's infrastructure anymore. So VS Code itself, for those less familiar, can actually be downloaded at code.visualstudio.com, but the entry point we gave to students was quite simply here, cs50.dev. And when students logged into this environment, what we essentially did using APIs, application programming interfaces provided by GitHub specifically for this product, we automate the process of creating for students a so-called code space in the cloud, which in effect is a Docker container and some associated storage. We automatically create for them a GitHub repository, which will ultimately store and back up their code. And we essentially, using these APIs, create a very turnkey solution, very much akin to what Cloud9 was, but now using a product that can scale all the more into the future for us. So here's a screenshot of the entry point that students might enter with after clicking login, logging in with a free GitHub account. The features that this particular environment provides are all of the languages we ourselves use, including support for C, for Python, for SQL, for HTML, CSS, and JavaScript, as well as a bunch of other languages as well. In fact, if you too are a teacher, you are welcome and free to use this same architecture with your students, even if it's disconnected from CS50, because the underlying software can support any and all courses using any of these runtimes here. The architecture, meanwhile, that we built essentially looks a little something like this, where if the user or student at my far right is logging into the system, they're essentially talking to a load balancer, which is in turn sending them to any number of front-end web servers. That in turn is talking to a database, as well as a GitHub repository, which their code might have stored back and backed up. Finally, connecting them to a so-called code space, one or more Docker containers in the cloud, and GitHub provides much of that backend. We therefore have focused primarily on the front end. Another appeal for us of VS Code is that it has a whole extension model, whereby using JavaScript, you can write code of your own that adds features to the graphical user interface of VS Code itself, so as to provide students with all the more features that might empower them to not only write code, but write code supported by tools that the course itself provides. Now, if less familiar, historically the way virtual machines work, typically those that we used in the cloud when we recreated the on-campus topology using AWS early on, and when we used client-side virtual machines in the form of the CS50 appliance, essentially the mental model to have is this. At the bottom of this picture, you have the so-called bare metal, whereby that is the actual Mac or PC or server that's running the software. You've got the host operating system, which might be Windows, which might be Mac OS, which might be Linux or something else, but on top of that, whatever computer you're using, you have indeed a so-called hypervisor, something like VMware or VirtualBox or Parallels or others. And on top of that software now, you can run one or even more virtual machines, each of which is running its own copy of an operating system. In our case, in the case of the appliance early on, it was Fedora Linux and later Ubuntu Linux, but it can be any number of other operating systems as well. Now, in our case, we simply had students in our appliance days running one virtual machine on their Mac or PC. Back in our early cloud days, though, we on our servers were running dozens, if not hundreds, of virtual machines on one single server for students. And ultimately, though, we've transitioned altogether to a different architecture, away from virtualization to something generally known as containerization, which in effect you can think of as lighter weight virtualization, where the picture looks a little something more like this. You've still got your bare metal, or the underlying hardware, the Mac, the PC, the server that you're using. You've got some host operating system, be it Linux, Mac OS, Windows, or something else. And now, instead of running a hypervisor per se, you run software like Docker, which is containerization software. And Docker then allows you to run one or more, and dare say many more containers on that same bare metal than you could historically with virtual machines, in part because the kernel or parts of the operating system are essentially shared across those containers, but in a way that should still be secure so that files are not actually shared across those containers as ways that users can access. So in this way, what GitHub Codespaces is doing, and what we might even do ourselves on some of our environments, is run software like Docker and then timeshare or slice up the computer's computing resources, including the CPU and the memory or RAM and more, into the illusion of lots and lots of tiny, smaller servers to which each of our students has exclusive access. And so their own files might be mounted within that same container, backed up thereafter, but during the time it's being used, far fewer resources are being used to sustain each of these containers than historically one virtual machine might have been. Now, as an aside, in the cloud industry, it's actually very common nowadays on bare metal to run a hypervisor which runs one or more virtual machines, and then within those virtual machines, you might still have containers, and in fact, you can even run containers essentially inside of containers nowadays, so this technology only continues to advance. But increasingly, thanks to Moore's Law, as we have all the more disk, all the more memory, all the more compute available to us, technologies like these enable us, and in turn our students, to make much more effective use of the hardware and, for our purposes, centrally control that user experience and all of the software within. Now, if curious, here's a quick tour of how we've implemented all of this underneath the hood, and you can do this through any number of ways, either manually in this one approach or through more turnkey solutions nowadays as well. Implementing a so-called container in the form of Docker is what's called a Docker file, essentially a text-based configuration file. Here are URLs to two of ours that tell the underlying container what software it should be running. So in the simplest form, a Docker file, again, a simple text file, might contain just these two lines. From Ubuntu, which says, give me the default Ubuntu image that Docker itself maintains. And then before I can even use this container, before any student can use it, run the command apt update and apt install -y Clang, GDB, and Valgrind. And what this will do for students is pre-install in each and every one of their containers Clang, which is a compiler for C, GDB, which is a debugger, and Valgrind, which is a memory checking tool. And students don't need to run any of these commands or any others or install anything themselves. Once the container has been built using this Docker file, it will just work in the ideal case. Meanwhile, once you've got that Docker file, in order to build this image and then make it available to students in the cloud or elsewhere, you can do a command that's essentially as simple as docker build-t cs50/codespace and dot, although there are certainly other command line arguments you can use. And then if you want to push it indeed to the cloud like we have, you might run a command like docker push cs50/codespace, and now it will be publicly accessible so long as you've signed up for a Docker Hub account for free online first. Meanwhile, there's even more configuration you can do, particularly for VS Code in the cloud when using something like GitHub Codespaces. Your so-called devcontainer.json file actually specifies not only the Docker image to use for a container, but maybe some additional settings as well. In the simplest form, a devcontainer.json file will say, build the following Docker file in the current directory. But more sophisticatedly, once you've got that Docker image built and ideally pushed somewhere into the cloud, you can additionally say, you know what, don't build anything locally, just use that image that's already up there, but add to the underlying container these customizations specifically and for instance for VS Code. VS Code indeed supports extensions, and so here we've specified that we want Microsoft's support for C and C++ pre-installed into students' code spaces. We want this specific setting enabled too, autocomplete for C or C++, but in this case, we actually overrode the default and changed it to disabled. The goal in our case being we want students to develop as much muscle memory as possible, so we try to simplify the interface and turn off a lot of these productivity features that are great to use a few months later, but not, we think, in those earliest days of the course. So in short, even though this is a simplification of the devcontainer.json file, and in turn the Docker file that we use, it represents the amount of control you can exercise not only on the ultimate software that's installed, but the user interface and features that something like VS Code itself provides. And so the end result, so far as students are concerned, is that when they log in, it just works. And they have this interface here, for instance, a simple file like hello.c, hello.c in the code editor. They can then, in the bottom right corner here, run a command in their terminal like make hello, which will automatically invoke something like Clang and allow them, therefore, to compile and later run their code. Now, most compelling ultimately for us pedagogically is that we can offboard students from all of this infrastructure. Even though it does indeed, we feel, solve a problem for us in the early weeks and months of the class, we want them ideally to stand on their own using VS Code or some other text editor or IDE at term's end. And so here, for instance, is the documentation that we provide to students in order to take those training wheels off at course's end, some 3 or more months later, so that ideally they are no longer dependent on any of this course's infrastructure. It's meant just to scaffold their experience in those earlier months. Now, if curious too, or if eager to have a headless version of the same, the teaching staff and I rarely log into the GUI-based version of VS Code in the cloud, but instead just use a tool we call CLI50 for Command Line Interface 50, which essentially uses a subset of all of those settings and pre-installed software that we saw before, getting rid of the GUI so that on our Mac or PC, we can very quickly have a headless, a graphicless version of the same environment that students might have, just to do more efficient development on our own machines locally. And so, for instance, if you were to run this command after installing it per the instructions there, you would have a mount of your current directory inside of a Linux container, running in this case Ubuntu Linux, and we even handle some forwarding of TCP ports for the web-based programming portion of the course and more. In fact, you can run this even without our pre-installed command. If you want access to the image on your own Mac or PC, once you have Docker installed, you can run docker run-it CS50/CLI, and it too should just work on your own machine. And in fact, if you don't want to use anything related to CS50, all of the principles here are the same. You can run your own copy of a minimalist Ubuntu installation by doing docker run-it Ubuntu, and it too should just work. Now, if you don't want to build any of this yourself and develop these same Docker files and devcontainer.json files nearly to the same extent, you can actually do all of this turnkey by using a product called GitHub Classroom, which is from our friends at GitHub as well. If you go to classroom.github.com, you can create some repositories in advance that essentially serve as template repositories that students can clone. And optionally within those, you can in fact create your own devcontainer.json file pointed at any number of actual Docker images in the cloud, and specify those key value pairs to configure VS Code exactly as you see fit for any settings or extensions that might be of interest to you. This obviates the need for having something like CS50.dev in our case, or writing any code that talks to the underlying APIs. GitHub Classroom is essentially a turnkey solution analogous to what we ourselves have built over the years. And as of time of publication, CS50.dev and this whole infrastructure has been used by quite a few students and teachers around the world, as many as 700,000 plus, 1,000 of whom were active per day, and typically on average some 10,000 active per week. So the technology, I'm very happy to say, all these years into this experience, works quite well and indeed scales. In fact, as some of students' own words when we surveyed them as to their experience educationally in the course using these tools, quote unquote, everything just worked, said one student. It made the whole setup process a lot easier, so the focus was more on the learning, said another. The results from our perspective, meanwhile, were both positive and negative, though I dare say overwhelmingly positive. It did in fact meet our pedagogical goals. It allowed us to focus on hello world and the underlying concepts of the course in those crucial earliest weeks, so that students aren't turned off by technical support difficulties alone when they can't necessarily distinguish what is just a technical support problem and what's an actual curricular problem or challenge with which they might need some pedagogical support. It's standardized, as we set out to do, students' programming environments throughout the duration of the course. And most importantly, in this latest incarnation, it eliminated system administration for us. We do, yes, create the Docker file and the devcontainer.json file, but wonderfully our friends at GitHub handle all of the back-end stuff that was creating emails and late-night calls for us in the days where we were managing all of the actual servers and connectivity ourselves. Now, that said, it wasn't all positive, and these remain challenges to this day for us. We've not been able to simplify the user experience for students as fully as we might like. The reality is, even though VS Code has this extension model and so many settings that you can specify in your JSON file, there's not quite as many as we would like. And ideally, we would turn off even more of the built-in features nowadays, but we just don't yet have the hooks therein. And insufficient offboarding was sort of a mistake that we made early on, whereby as much as we like the idea of getting students off of the cloud and onto their own Macs and PCs by course's end, so that the training wheels were indeed fully off for them, we just didn't message this enough or provide enough training at term's end to make this a seamless transition. And so in future semesters, it's been a goal of ours to make sure that we're actually practicing what we're preaching and ensuring that when students exit the course, they no longer feel any dependency on it, but indeed can go back to the arts, the humanities, social sciences, physical sciences, computer sciences, and still apply those same lessons learned while standing on their own 2 feet with their own hardware. Among our other future work, we hope to integrate all the more auto grading within the containers themselves. And in fact, thus far, we've generally been doing our auto grading off devices and in our own cloud-based environment, which is yet another thing that we ourselves have to maintain. But insofar as we have full control over this underlying Linux environment, we hope to automate a lot more tasks for students and TAs alike in situ within these same containers themselves. For these slides and all of the files and URLs documented herein, please feel free to scan this QR code. In the meantime, my name is David Malin, and this was Containerizing CS50.